In this example, I'm going to show you how to use the greatest common factor method to factor polynomials. So I have three separate polynomials we're going to factor in this video. The first one you can see here, part A, is 12x to the fifth minus 4x squared plus 8x cubed z cubed. So when you're using the greatest common factor method, what we're looking for is the greatest common factor. So remember that the greatest common factor is the largest quantity that is shared between all the terms in the polynomial. So I see that the greatest common factor for this polynomial has to have a coefficient that divides into 12, 4, and 8, and is the largest number that does so. And that number is going to be 4. All three of these terms have factors of x. This one has 5, 2, and 3. So they at least all share 2 x's. And then I have z's here in this last term, but no z's here, so that is not a common factor. So the GCF, or greatest common factor, for this polynomial is 4x squared, and I'm going to factor that out. So 4x squared goes out front as a factor. And to determine what's left behind, what I'm going to do is divide each of these terms by this greatest common factor. So I'll go ahead and write that in. Okay, so sometimes you can do this division pretty easily in your head, other times not so much, but this is really what's going on. So again, I've factored this out, and to determine what's left behind, I need to divide everything by that quantity. So I can combine coefficients by actually dividing 12 by 4 to get 3. X to the fifth divided by x squared. We use our exponent rules to combine to get x cubed. Minus a quantity divided by itself is always just 1. And then plus 4 goes into 8 2 times. X cubed divided by x squared is x to the first, and I still have z cubed. And so that's what's left inside the parentheses. So I see there are no more common factors between these three terms. It has to be something that all three share. So I am finished factoring this problem using the greatest common factor method. In the second polynomial, I have two terms, negative 24a x squared minus 60a. So again, I want to identify the greatest common factor of all the terms in this polynomial, just these two right here. So first, notice that both terms are negative. So the greatest common factor is going to be negative. I need to find the largest number that divides into 24 and 60 evenly. And I know 12 divides evenly into both of these, and I think that's the largest one. And then I see they both have a single factor of a. And this term has an x factor, and this one does not, so I can't include x over here. So again, I'm going to factor out this greatest common factor, negative 12a. And what's left behind, I need to divide everything in negative 12a. So we'll go ahead and combine like terms again, the coefficients. A negative divided by a negative yields a positive. 12 goes into 24 2 times. A single a and a single a cancel, and I still have that x squared. Again, negative and negative cancel, leaving behind a positive. 12 goes into 60 5 times, and a divided by a is just 1. 5 times 1, 5. There we go. And again, you see what's left behind inside the parentheses. There's nothing left in common between these terms. If there is still something in common, if both these terms were divisible by 2, that means we didn't actually get the greatest common factor. We just got a common factor. If both terms were still divisible by, let's say, 2, then you'd need to repeat this process and factor out that 2 that they share. But these are not both divisible by 2. They share nothing, so that's my final answer. So in the last example here, part C, you can see I have some parentheses here on some quantities. But I really want to point out what the greatest common factor is. So in this case, it is in your best interest not to multiply. Do not distribute. Do not combine like terms. It's set up like this for a reason. So first I want to point out that the coefficient on this term right here is a 1. I also want to point out that a squared minus b is in both terms, which means a squared minus b is a part of the greatest common factor. Now this coefficient is 1, this coefficient is 3, those aren't really divisible by the same number, so this is my greatest common factor. So what I'm going to do is factor that out. And what's nice about this is that the division's really easy. So when I divide 1 a squared minus b by a squared minus b up here, that entire factor is going to cancel. Minus 3a squared minus b over a squared minus b. Again, that entire factor cancel. So I'm left with a squared minus b times 1 minus 3. So then, what's 1 minus 3? We can actually combine these like terms. So this is a squared minus b times negative 2. And if we needed to, we could distribute this coefficient in, but we were asked to factor, so we're going to leave it like this.